Hello guys. So today I am going to show you how to create a linked list in Java. Okay. So the very basic structure of linked list is like this. It has a this is a node. This can be defined as a node. Okay. And this node has two parts: a value and the address. The address of the next node actually. Okay. So this is suppose of this is a linked list. Okay. So the address of this node is 1200. This one is 1201 and this one is 1202. So there is a value part and the address part. Now this address part holds the value of this holds the address of this node. Okay, the address of 12000 holds the address of 1201. Similarly, address of 1201 holds the value of 1202. Okay, and so this is the basic idea of a linked list. Uh, and one more thing I want to say before I go. See, the first node in the linked list is considered as head. Okay, head. Uh, Now head is never changed. Head remains the same all over the all over the program. The head will always point to the first node. Always point to the first node. Okay, so let's start the program. Here is a class I created for a linked list. Now we need to create another class which we will name as node. Node will have two parts, right? One is int, which is value, which is the value of the node, and next is a node type variable called next. Now why is it node type variable? Because this this is actually a pointer. Okay, next is actually a pointer, though Java does not have the concept of pointer, but still it acts as a pointer. This next is going to point to the next node, and that node is also of the type node, right? Seems a little bit confusing at first, but when we progress you will understand. Okay, so we create a constructor here, public node and int val. Okay. Now this dot next equal to null. This dot val equal to val. Okay, this what this does is it creates it points to the object which we are currently using. The object which we are currently using, that is the value, that is a node we are going to create. The value of that particular node only will be the value, not the second one. Okay, now we have the main program. Okay, now one more thing we need to do is we first need to create the head, right? Because it will remain constant all over the program, so we will define it globally so that all the functions can access it. Static node type variable head. Okay, head equal to null. Now scanner is equal to new scanner. What scanner class does it takes the input from the input stream and provides it to the program. Okay, for let's create the input function first. Static void insert, and the parameter which will be passed is the value. Now we take node equal to node ptr equal to new node of value. Now when we are writing node of value, that means this value, the value entered by the user, this value. Okay, say we'll name it as value only. Okay, and here also we'll give it value. Okay, this value is now here, it comes here, and value val becomes value. Okay, so the if we represent the link as this one, so now this becomes a value, and the next part is null. Okay, if this is considered as the linked list. Okay, let me just zoom it for you. Val becomes value, and value, here is the node. The node has this value, and the next part is equal to null at this moment. Okay, now we check if head equal to null, then head equal to ptr. So as I told before, that the first node will always be head. Okay, so if the whole list is empty, then head is also empty. Head is also empty or null, right? Anyways, uh, so if when the first node is inserted, we treat that as head. Sorry. Okay. Now if else, we take another node type variable, which is temp, which will use traverse the linked list. Okay, now node temp equal to head, while temp dot next not equal to null, we traverse. Okay, while temp is not equal to null, we traverse the whole array. So temp equal to temp dot next, and when we reach the last of last node, okay, then we will find that it is null, right? Here it is null. So if we want to add another node, then we will create, then we have this node, right? We have suppose this node. So what will happen when it finds null? It will just link this node to this one. Okay, that is what we are going to do. So temp dot next equal to ptr. Ptr is this node. Ptr is this node. Okay, ptr is this node, and at the after traversing, temp is this node. This node is temp. Okay, so temp dot next equal to ptr. So this becomes our insert function. Now we'll just take it from the user. Okay, so here we are just passing the value to 5 functions, and just make another function which is display function. Okay, static void display. Now what will display function do? It will just show the whole thing, right? Now throughout the whole program we have not changed the head, right? So node ptr equal to head. Okay, so this ptr is now also pointing to head. Now what we'll do, while ptr not equal null, system.out.println ptr.val and ptr equal to ptr.next. Okay, now one thing that is very important is this ptr not equal to null, and what we did here, temp.next not equal to null. Okay, so okay, if we just, you will understand the difference very easily. If we just name it as temp, they are same. Okay, we can name it as anything. Just for sake of argument, let's name it as temp. Here, there is a difference between this and this. You see, when we are using temp.next equal to null, it will stop here. Okay, it will stop here. It will not print this value. It will not print this value. Okay, but when we are using temp equal to null, that is um, this one and the next one is null right now, right? Okay, this one is next is null, so then temp will go here, and when it will be there, then only the loop will stop. So in that case, it will print this, temp will be here. In that case, that it will print the last value. The last value will also be printed. Okay, if we give ptr dot next, then it will not print the last value. But if we give pt temp equal not equal to null, then it will print the last value. Let's see if the program runs. Just a second.